Hello everyone, welcome to my presentation. My name is Yujie. I come from Southern University of Science and Technology, Shenzhen, China. I'm very glad to have this opportunity to attend the conference. The topic of my presentation is charging rate transaction mechanism and grid charging stations based on blockchain techniques. I'd like to divide my presentation into 5 parts: introduction, overall framework, transaction process, formulation, case study, and conclusion. Why I choose this item? With the opening of the power market on the distribution network side, the number of prosumers will greatly increase and the transaction will become more frequent, which will cause the pressure of the management center server to increase, the efficiency to decrease, and especially to be low. Therefore, building a decentralized power trading platform and mechanism is one of the urgent problems to be solved in multi-grid charge-state trading. Blockchain has the characteristics of decentralization, tamper-proof, which can provide a feasible way for power trading and can effectively solve the problems of the power trading centralization and low efficiency. Based on this paper proposed a multi-grid charge stations network intelligent transaction strategy based on blockchain. The intelligent transaction framework of charging rates of multi-grid charging stations based on blockchains shown in Figure 1. And sort of data side, charging rates can be traded in the blockchain since it's impossible to predict the exact charging demand. This paper sets each transaction period as 30 minutes. The smart contract in this paper writing is selected, then the data is packaged and compiled into code. The smart contracts occupy CPU and consume gas during automatic execution. The smart contract model is shown in the figure 2. At the beginning, the grid charge stations enters the block after signing the contract, then organizes the external data, checks whether the trigger condition is met, executes the transaction, and finally waits the transaction verification. First, we define a boundary price in a multi-grid charge station system for the bearer, where the boundary price is the ceiling price of the distribution network. As for the seller, the boundary price is the purchase price from distribution network rate to reflect the risk attitude of buyers and sellers towards the market competition. The transaction risk factor real number in the range of -1 is introduced. The transaction risk factor can be adaptively updated according to the results of the previous round of the transactions. First, we consider continuous double closure market clearing. Then, the ideal bid price of the transaction nodes are sorted according to principle of price, priority, and temporality. The two parties of transaction are matched in sequence according to the Qi and electricity qualification scale. The contract electricity price is the average value of the ideal electricity price of the both parties, as in equation 4. After the centralized method of CDM market transactions, many buyers and sellers enter the continuous bidding stage. Participants in the market must modify their biddings in order to complete the transaction. After 2 stages, bidding by each, the market clearing takes the node created into account. The amount of transaction charging rights is the minimal value of the contract charging rights between the two parties. The number of contract profits calculated as following equation 6 to 8. Due to the fluctuant photovoltaic power generation and the error in the prediction of the electrical vehicle charging load in the grid charge stations, it's determined that the concluded electricity transaction cannot be 100% executed according to the contract. So the following 4 situations will exist in the actual settlement. The load credit score is combined with the consensus mechanism. In this mechanism, the probability that load obtains the current block according right can be calculated by the equation 11 to 13. In this paper, we use the ID Remix platform and the S3 asset management wallet MetaMask to deploy the test smart contract and add 11 virtual accounts to the contract to simulate the address of the grid and 10 charging stations. The parameter of the 10 grid charging stations in the park at a certain time are shown in table 2. We can conclude that B1, line 3, and A10 to 6 complete synchronized match in the continuous double closure market, ensuring the reliable of power supply and consumption. B7, 5, and A4A failed to reach the transaction and enter the second stage of continuous bidding. According to equation 5, the remaining grid charging stations to facilitate the trade by just quotes the bidding profiles in the continuous bidding stage as shown in figure 4. From January to May, the summary of smart contract execution is shown in Table 3, which repeatedly experiments the success rate of smart contract execution increased from 91.21% to 93.96% for the following two reasons. Improving the consensus mechanism can improve efficiency. Optimized smart contracts can meet the complex electricity trading system. Similarly, we analyzed the reasons for the failure of contract execution and summarized them as the following 3 points. The security deposit of the electricity purchase is insufficient. The gas of the smart contract issue is exhausted. The system is unstable. We can conclude that Table 3 that the time each transaction in different experiments is close to 1 second. If we want to shorten the transaction time, we must solve the problem of comparison of high redundant data resources. We consider the total number of charging stations is set to 10. The credit score is between 0.8 and 1 by testing the accounting ownership of 50 blocks. The relationship between the load credit score and the probability of success for many is obtained as shown in figure 5, which can be seen that the probability of success for many of a load is positively related to its credit score, and the credit score of a node decreases the probability of success for many decreases repeatedly. If credit score is lower than 0.9, it's almost impossible to success for many. It can be seen from figure 5 that the deviation between simulation value and reference value is small. In this paper, the charging rate transaction mechanism based on blockchain is proposed. The combination of blockchain and continuous double equation aims secure, transparent, and independent peer-to-peer transaction among grid charging stations. A decentralized and complete transaction process based on blockchain is proposed. In contrast to existing works, the proposed strategy can effectively solve the problem of centralization and low efficiency of electricity trading. A bilateral bidding strategy considering adaptive lambda is established. The lambda reflects the risk attitude of buyers and sellers towards market competition, which can be adaptively updated based on the result of the previous round to encourage each load to participate in the transaction and perform the transaction according to the contract. A lower consensus mechanism considering node criteria is applied in the blockchain different from existing works. The higher the credibility of the load, the greater the probability of obtaining the counter right. Okay, that's all my presentation. Thank you for your listening. If you have any question, please feel free to contact me.